Perfect. Great. All right. Good morning, guys. Thank you for joining us. And we're hoping that this would be sort of the first of a series of webinars or seminars or meetups that we are planning to organize to dive a little bit into the topic of blockchain. So basically today we wanted just to have a general overview of what blockchain is. I will be looking at the technical side of blockchain. Then after Hamid will be looking at the financial side. You know, we hear a lot about Bitcoin, cryptocurrencies in the last few couple of months. You hear a lot about NFTs. You hear about DeFi, distributed finance. There are lots of jargons and new words, and you know we cannot cover everything in 2 hours. So I want to start with a very general, very broad presentation. Then later on, if you are interested, we can basically have dedicated meetings or dedicated seminars for each one of these topics. And so again, please feel free to interrupt me if you have any questions. Otherwise, as I said before, we'll have a Q&A session at the end. So again, the goal is to talk about blockchain and what is it made of, and what is the purpose, or what are the scenarios in which using blockchain makes sense. Because you know people want to use it everywhere, but there are many cases in which blockchain is not really the best choice or the best technological choice. So before talking about blockchain, just to motivate a little bit the discussion, I wanted to go very briefly and talk about why why do we need blockchain, or what existed before blockchain. And I think we all know as human beings, you know, we live in groups and we live in societies, and we were always looking for ways to establish trust in order to basically increase collaboration. And when it comes to small groups, this is easy to manage because we know people, and we basically create, through interactions we can establish the trust. But as civilizations and economies grew, it became a little bit more problematic to manage trust. So one of the first attempts, or one of the first mechanisms that people use to establish trust is what we call this signet ring. So people had their own signet rings that they basically use as a stamp. So when we have a transaction, we can stamp it with that signet ring, and that will establish trust. Because when I receive a letter or a decree or a contract from someone and it is signed using their signet ring, I can be sure that that contract or that transaction comes from a certain person. But the problem, as our economies or trading grows and transactions became worldwide, it became very difficult to use this mechanism. So this mechanism does not really scale that much. So we started looking for third-party, what we call third-party trust intermediaries. Because if I live in Italy and they need to trade or do some business with someone in Japan, I need to have an intermediary in the middle that would guarantee, or that it would establish that trust relationship between the two of us. And if you think, we have so many of them, you know, starting with banks, you look at Amazon, we have Google, we have all sorts of governmental organizations that act as a trust intermediary between two parties. But the problem here is that when we have this third party, we have what is commonly referred to as third-party tax. Because if we have a third party in the middle, definitely it adds costs, it adds time, and it adds risk. It adds costs because those intermediaries, they themselves have their own operations to maintain. So we need to pay them basically for the work they are doing. It costs time. So imagine if you need to send money from here to Japan, it takes time because the money will go through a hub or like a chain of intermediaries till it gets to its final destination, and that costs time, and then it costs risk. Because if, for example, a bank gets hacked or someone managed to basically access or compromise their database, we are put at risk because our data is managed by them, and basically it could be compromised. So the challenge here, and actually this adds more challenges, And one of the biggest challenge is that one way that the current infrastructure works is that every one of us needs to keep sort of the records by themselves. So we have, an insurance has its own database, a regulator, we have employees, we have companies, everyone has its own copy of what they consider to be the truth to them. And if there are conflicts, the only solution we have is to go to the court and try to, basically everyone brings their own evidence to show that the records they have are the sort of the more the real or the truth in a sense. And this approach is very inefficient. It is expensive to manage, and also it is vulnerable. So our ideal scenario would be, okay, why can't we have one not centralized, but one single source of truth, one single book in which all transactions are stored, and whenever any one of us needs to basically check any fact, they can refer to that. So generally, this is what we would consider to be a distributed database. But the problem that, like the first question that comes to mind, who manages this database? Who are the administrators? So we want it to be shared, but we don't want to have anyone who has control over it. So the properties that we are looking for is immutability. So we don't want anyone to be able to change or modify or tamper with the data in that database. We want to have provenance. So every piece of information that is stored in that database, we want it to be traceable. We want to see who put it there and how it moved through the database. And we want also to have a consensus. So before allowing anyone to put some information in the database, we want all the network to come to a consensus to decide whether to accept that piece of information or not. And plus, we want to optimize the three cost taxes. So we want to optimize time, risk, and time, cost, and risk. And this is where basically blockchain comes. So blockchain is a distributed database, or as we refer to a distributed ledger, that basically addresses all these concerns. So just going through a sort of formal definition, so blockchain has been defined as a decentralized, generally public database that can record, actually it is decentralized and distributed database that can record transactions in a verifiable and permanent way in a trustless environment. So we don't need to trust anyone in that network. And the goal here basically is to solve what we call the double spending problem. So just to give you an analogy, when we talk about like physical transactions, I give you money and you give me a good. And I know that, the moment you give me that $50 or $100, it will change ownership. So it used to belong to you, now it belongs to me, and it's done. When we move to digital transactions, things become a little bit tricky. Because if I send you a transaction, if I send you $100, I can make another copy and send it to someone else. And the only possible solution that we have now is to do it through a trusted intermediary. So if I send you money through the bank will make sure that when they send you the $100, they will remove it from my bank account. So here we want basically to reach the same level of trust to solve this problem, but without having any third-party authority. And the vision here is basically to distribute the decision-making power among all the participants of the network, instead of having only a single or a group of people who have control over it. And this sort of ledger, it's something that existed since the old times. The advantage we have now is that we can have shared and distributed ledgers that are stored across thousands or millions of machines across the globe. So what I would like to address in this presentation is basically to look at the building blocks of blockchain. And by the way, these building blocks, because sometimes when we hear people talking about blockchain, we think that everything that is sort of that makes up blockchain is new, which is not really true. The technologies that basically power blockchain all existed before. But the way they have been put together to come up with this, groundbreaking idea is the thing that makes the difference. So if you see here, we have basically 4 building blocks that make a blockchain network. And of course, these are like the building blocks of a typical blockchain network. Because as you may have seen, every day there are new blockchain platforms coming to existence, and some of them, they extended the basic idea. And one more thing I should mention here, that most of the examples I will be giving, I refer to Bitcoin and Ethereum. Of course, some of the platforms extended the ideas, they added other blocks, but here the goal anyway, just to understand what a typical network looks like. So we have peer-to-peer networks, we have hashing algorithms, asymmetric encryption, and the proof of work. And we try to go and look at each one of them in turn. And before doing this, I want just to go back very briefly to the start. So everything started with this paper, which is called Bitcoin, a peer-to-peer electronic cash system. This paper, actually, it was published in November 2008 by, what is believed to be a pseudonym of a person or a group of people called Satoshi Nakamoto. And in this paper, basically, this paper lays the foundations of a peer-to-peer based system for performing or making financial transactions. And it shows that all the properties that we have mentioned before could be achieved without relying on any third-party intermediary. And here, this is actually the link to access it. And this paper, actually, the paper came first, and afterwards, the first implementation was published in 2000, actually in January 3rd, 2009. And let me just go very briefly here. If I take this link, so if you go here to SourceForge, you can find here the source code of the first implementation of the Bitcoin network. Plus, if you go here, it was here, this was the first transaction that was made in the network. And if you see here, the first transaction, actually, the total amount received by this transaction was 68 Bitcoin. And you can also here see the fee, the hash of this transaction, something that we'll look at very, very briefly. And let me just, oops. Let me go to the presentation. I want to grab another link, which is, no, I don't have it here. No, I will find another link for the transaction with more details. But basically, the idea here is the first, what we call the Genesis block, the first block in the Bitcoin network was published in January 3rd, 2009. So now we'll look at each one of the building blocks. So the first building block is peer-to-peer network. And peer-to-peer network has many advantages. So the first one is does not, cannot be censored, because we have computers that are located in different parts of the world, and it's really difficult to censor. It is a highly available network, and it is also fault tolerant. Plus, it does not need any special equipment. I can, if I have all, all I have is just basically connect my computer to the network, install whatever client or whatever piece of software needed to communicate. And I think if you guys had experience with Gnutella or Napster, or I mean BitTorrent, you understand how these systems work. So this was the first idea. And if we take Bitcoin as an example, so in Bitcoin, all the nodes are equal. So there are no special nodes. Just to give you a comparison, if you take, for example, Napster as an example, Napster had some sort of master nodes that basically manage the network, and so we had these masters and slaves. Whereas in Bitcoin, all the nodes are equal. So if you install that software and you join the network, you will be as any other node in the network. And the interesting thing that you see in most of the blockchain networks, that by design they manage digital cash. So for example, in Bitcoin, if you want to send money, you need so you make the financial transaction, but in order to do it, you need also to pay for the transaction to be executed. So it is something intrinsic into the network. This is the first block. The second block is cryptography, and cryptography actually is used because we want to understand. We know that in the network we'll have different participants, and we want to understand who sends messages to whom, and whether the messages are valid. So if Alice, let me go here, and we can basically achieve this by using what we call asymmetric encryption. So every participant of the network has a pair of keys. They have a public and a private key. So basically they create the transaction, they can sign it with their private key, and all the other participants in the network, they can verify it. So here, if I have Bob and Alice, so for example, Bob can sign a transaction with his private key, then afterwards Alice can verify that transaction by using the public key of Bob. So here, what happens in a blockchain network, when one machine creates a transaction, they can sign it and they can broadcast it to all the nodes of the network. And of course, here, depending on what platform, what blockchain platform, we can have different broadcasting strategies. And every node there, they can verify what happens or whether that transaction is valid or not. So this was the second building block of a blockchain network. Then the third building block is what is hashing. And hashing is used very heavily in different operations in the blockchain. And as you can see here in the top of this figure here, we have this hash, which basically it is a fingerprint of, it could be a fingerprint of a transaction, but it could be also a fingerprint of a block. And here I will take just a moment to go and show you a demo here. So I think that all of you are already familiar with what a hash is. So basically, hashing is an algorithm, and for example, in case of Bitcoin, they use SHA-256 algorithm, but we have the variety of hashing algorithms. The goal here is, independently of what input I give, the output will be always a fixed length string that we call the hash. And if you see here, even when I change only one single character, the hash totally changes. So it is a one-way encryption in a sense, that from every input I can get one hash, but I have no way to go back, starting from a hash, basically to recover what the data was. Okay, so this was the first thing. Now I will go on, then we'll come, because here the second idea will be the block. But I want just to start with what a hash is. So now it gets more interesting. We said that, okay, the blockchain, basically, as the term itself refers to it, it is a chain of blocks. So what is a block? What a block is made of? Now I will go back again here. So we said we have this data block that we can put some information, and we know that for every piece of information we have a different hash. Now I will go to the block. So instead of having this data field, just one single container, we create a block, and block, basically, it's divided in three parts. We have the block number, or the block ID. We have what we call the nonce, and we have the data. So basically, in this data field, I will have my transaction. So for example, I can say that Nabil is sending to Hamid, for example, $100. and I can have other names here, Bob and John, or Hamid is sending me some. Okay, here Hamid can send me $1,000 and so on and so forth. And one thing that you notice here that the block changed its color to red. This is something we'll talk about shortly. So basically, I will put my transactions here. Now, what is next? So we said my goal is to take this block and add it here to the blockchain. Then who does this operation? Because our ultimate goal is to have, we said before, we are operating in a peer-to-peer network, and our goal is to have that blockchain duplicated, or we have copies in every node of the network, okay? And once we have this copy, now it's time, people make transactions and send them to the network. So someone needs to take the block I have here and basically attach it to the existing chain. Who does this? And this is the role of what we call the miners, or this is the mining process. So the mining process, basically, the goal of the mining process is to add new blocks to the blockchain. And in order to do this, since we are operating in a trustless environment, we cannot just let anyone do it. Because if we let someone do it, maybe that person could be a malicious user. So we want to make it in a fair and trustless way. And the way it is done in Bitcoin is through a public competition that is open to everyone. So we said all the nodes have equal rights. So everyone in principle can participate into that competition. And the goal is to solve a complex math problem, which in this case relies on hashes. And the first person who is able to win or to sort of solve that problem have the right to create the next block in the blockchain. Plus, that person we need also to give some incentive to that person. So basically, that person will receive an incentive composed of two things. The first one, it will receive an incentive from the network, and then it will receive also the transaction fees. So if I go back here to my example, this will not really look like this. So if Nabil is sending to Hamid $100, plus I will send, let's say, $1 as a transaction fee. So the miner will also receive this amount of money as payment for their work. And let me go here. Then I will come back to the example to explain why the block is red. And this idea of this competition, it's something that was invented in 1997 by Adam Back, and the whole idea behind it, it was called Hashcash. The idea was used basically to eliminate spams. So I think we all receive spam emails all the time. The idea was, okay, what if, we can use it also for web application. Because, for example, if someone is trying to attack my system through a denial of service attack, their goal is to send me a huge number of spam requests that basically will crash my system. The idea behind Hashcash is the following. Every time I receive a request from, it could be from a client or someone send me an email, before sending them back the content of my page, I send them a very small computation to do. And once they do it and they send it back to me, I will give them the content. So imagine if every time you request a web page, I will give you something to compute that will take you 1 second. So the more requests you send to me, the more seconds you need to spend before receiving the content. And this has sort of the power to make, you will not block my system, but you will make your system heavy, since it needs to perform lots of computation before receiving any responses back. So how do miners use this idea in order to generate sort of income from the blockchain? Once we'll go here. Once we have this block ready, we ask the miners basically to combine the content of the data, of the nonce, and of the block ID, and to perform a specific computation. And this specific computation will be basically finding a hash with the specific attributes. And in the case of Bitcoin, they need to find a hash that starts with a number of leading zeros. So in this example here, in order to have this block to be valid, I need to find a hash that starts with 4 zeros. How can I do it? The only way I can change my hash is basically I need to change the information here. It is a brute force approach. I need to keep changing information till I find a hash with 4 zeros. But here is the catch. I cannot change information inside the data because if I change here, I will compromise the transactions. I cannot change the block number because this is fixed. So the only thing I can change is the nonce. So the nonce here, basically, it is a random number that I keep changing in the hope of finding a hash with leading zeros. So I can do it manually. I can go and try 1, no, 2, no, 3. I keep trying. So it is basically a brute force approach. So now if I click on mine basically, it does this behind the scene for me. And it takes a little bit. Okay, now it found that if I use this hash, I get basically a valid hash for this transaction. So if I change it, no. If I come back here, it is considered to be a hash, like a valid hash. All right, so this one to basically validate the block. Then we have the second part. As part of the miner's job, they need also to validate the transactions. And in order to validate transactions, they perform a number of things. So in order to validate transaction, they need to check some what we call consensus rules. That, for example, every transaction has been signed correctly, that it has never been spent before. Because, you know, if I say here that I want to send $100 to Hamid, part of the validator's job would be to check if I own $100. Because if I don't have $100, I cannot send it. So they need to check this. Then they will also check the block. So for example, they check if the size of the block is correct, if the reward is not spent less than 100 blocks, and there are other, and for example, they check the hash of the block and so on and so forth. And this basically will allow them or will give them a chance to keep brute forcing in order to find the right nonce for the block. And as you can see here, if you check also in the different platforms, you find here that this is the nonce and this is the block reward. So for example, for this transaction, this was actually the if you see here, the height is 0. This was the genesis block of the Bitcoin, and the block reward was 50 Bitcoin. All right, so we have talked about this. Okay, and the other thing to mention here is that the network basically will adjust its difficulty level, because in the case of Bitcoin, we want to be able to generate one block every 10 minutes. So the network will adjust the difficulty in order to make sure that every 10 minutes a new block will be generated. And this one just it goes a little bit more in detail to see that the hashing will take the current and the previous blocks plus the nonce. Okay, so this is something that we haven't seen yet in the example. So here I'm talking about one single block. Now, if I go to the next tab here, by the way, this is a very interesting website. We have it in the slide if you want. You know, it gives a demonstration on how the different concept of blockchain work. So as you see here, we have added something else. So before we said that we have the block ID, the nonce, the data. Now we have also the previous block. And this is the idea of the blockchain. So we connect the different blocks by linking every hash. So here we use the hash of the previous one. Now, this has a very critical role. Because now imagine if I come here, imagine someone manages in my, let me go back in this network. We said that all the nodes have a copy of all the chain of the blockchain. Now, if I own this machine and I want basically to manipulate the data here, what I can do, I can come to this node, to this block, and I can modify it. So if I modify this block, I will invalidate it. And again, I need to mine the data here. But imagine if someone wants to go and change something in the previous nodes, in the previous blocks. So the moment I change something in one block, I will invalidate all the blocks that come after. So this one makes it really tamper resistant, because every time I make only one change, I will affect all the nodes, all the blocks that come after. And in order now for me to be able to push or to broadcast this change and to be accepted, I need all the nodes here to come to consensus with me. So if I make the change, I need all of them to accept what I do, and this is almost impossible. It is possible in one case that we will mention in few slides. All right, let me go back here. All right, and here just to give you an idea of the rewards that always here, as I said before, I'm referring all the time to Bitcoin, but the same thing applies to other platforms with some differences. So when Bitcoin network started in 2009, every time you generated or you were sort of accepted to generate a new block, you would receive 50 Bitcoins as reward. And this reward actually gets cut in half every 4 years, more or less, because in total, we only have 21 million Bitcoin. So every time it gets cut by half, and now it's about 6.25 Bitcoins reward for each block generated. That's why many people actually were interested in doing mining, because it's one way to get some income through the rewards you get from the network plus all the transaction fees. Okay, the other concept to mention here are the transactions. So how are transactions managed by the network? Bitcoin uses a concept called the unspent transaction output model, and this basically it's very simple. We go to here just to give you a real example. So, for example, if you want to give money to someone, all we do is, you open your wallet, you take $10 or $20 and you give it to a person. Because when you open your wallet, you can already see how much money you have there. When it comes to Bitcoin, it's different. We don't have basically like a variable or okay, let's call it variable, where we store what is the current balance of my wallet. What we have is what we call this unspent transaction output. So I only have all the input I have received and all the output that I have spent. So if I want to send you money, I need to do something like this. I will take all the transactions where people have sent to me some money and subtract all the transactions where I sent to someone some money. And the difference will be my balance. This is something that requires us to scan all the history of the blockchain in order to find it, but we don't do it manually, because most of the wallet applications will do it behind the scene for us. So when you open your wallet, you see that you have this amount, but in reality, what happens is they need to go through all those transactions. And if I want to send some Bitcoin to someone, I will take all the transactions where I have received some money, I give them as input, then the output will be part of that money. So imagine if I want to send let's say I want to send $5 to someone, and I check my history, I find that in one transaction, I find like I have received 3 transactions with $2 each. So I will put these $3 as input, and the output will be, one output is the transaction with $5, and the change or the rest will come back to me. Plus, I need also to include the transaction fee that will be charged by the miner, so to pay the miner for their sort of mining process. All right, then once I have this transaction, I submit it, then the miner will package it inside the block, and that block will be sent across the network to be validated. And if the validation process works, if all the nodes accept that transaction, it will persist, and we go to the second cycle. One important thing to mention here is that we said that it is a public competition. So in principle, every node in this network is trying to generate the next block. And there are, and this block is generated every 10 minutes. So there are occasions in which more than one node can generate a block at more or less the same time. So what happens in this case, so this is sort of a conflict, and we need to resolve it. And if we take Bitcoin as an example, the way that he solves is we wait again for the next block. So for example, here, if you see this block on the top, we are at block 103. And now in the next iteration, we find ourselves that we have two blocks. We have 104A and 104B. So which one we would consider to be the valid one? The approach that Bitcoin uses is to wait for the next block again. So we wait for 105. And as soon as we see that 105 has been connected to 104A, this would be the valid path. So the longest branch win in this case. One downside of this, and this is actually one downside of this proof of work, this approach that we have mentioned before, this public competition is called proof of work, has the downside that it consumes lots of energy, and that even, for example, now the block 104B, even that the person who generated that block has spent some energy in order to generate it, I mean, he or she will not get any reward because that block will be discarded.
Sorry?
Yes, please.
May I ask a question?
Yes, please.
But how do we actually know to which block we attack next if we have a dagger with multiple ends? In this case, how we decide to attach to A instead of B?
No, actually, so here what happens, the person who generates the 105 will broadcast it to the network. And there, the goal is to see how many people have received that block and attach it to the existing blockchain.
But if they have two options, because we have two branches, how do they choose which one to append to?
Okay, so here the idea is we assume that it takes time for the network for the propagation of the blocks. So after 10 minutes, we are sure that not all the network has all the blocks.
Yeah, it's based on eventual consistency.
Yes.
Okay.
Okay, so as I said before, since we said that proof of work consumes lots of energy, so over the years, that was the sort of the starting point, but people started thinking of other approaches where we can reach the same level of security, but still consume less energy. And one of the sort of the widely recognized and used protocols is called the proof of stake. And the proof of stake, basically, it comes with a different approach in which instead of spending lots of energy, we do something different. So instead of having miners, we have a different concept called validators. And these validators, they will be chosen randomly to generate the next block. But again, here there is always the risk where we don't want to let any malicious user generate the next block. So how can we guarantee this? So the approach they come up with here is using a stake. So if you want to become a validator, you need to put some collateral, or you put some stake. So basically you put some money, and in case you misbehave, you will lose that stake. So in this approach, you will think twice before making any malicious move. And other than these two, there are plenty of other consensus protocols. We have delegated proof of stake, where basically we can elect different members to do the staking or the validation. There is a proof of elapsed time where we can wait. So a random waiting time is produced, and every time, like the node that reaches the end of a random wait period will be assigned or will be given the opportunity to generate the next block. And this is actually a whole topic by itself that we can talk about. I want just to give you a couple of examples. Before this is the point before last I want to talk about is what we call the 51% attack. Actually, when we come to security, there are other security problems, but this is one of the problem that is connected with the network. So as we mentioned before, in Bitcoin, the goal is to be able to generate the next block. And if I go back here, you've seen that in order basically to mine the block, all I have to do is all I need to have is a powerful machine that allows me, to brute force as many hashes as possible. So this means that if I have strong or powerful computational machines, I can perform more than the others. And this allows me actually, if I control more than 51% of the computational power of the network, I have the potential to manipulate the network. How can I manipulate it? So for example, we said before that I can edit some previously blocks, and I can create longer branches because I have the power, so I can always generate the next block, and I can put whatever I want in it. When we talk about I can put whatever in it, definitely I cannot create false transactions, because if I want to control or access someone else's account, I need to have their private key. But what I can do, I can basically create the double spending. I can for example, in this example on the right, I can spend, for example, 100 Bitcoin, but since that 100 Bitcoin, since I have control over the blocks that will be generated later, I can make it in a way that it does not show up in the ledger. So at the end of the day, even if I spend money, I can re-spend them more than once, since I have the power to control the next blocks to be generated and to be validated. So this is, again, since we have some limited time, I don't want to go deep into it, but if you are interested, we can talk about it more in detail. One of the important things to keep in mind that since the Bitcoin came to existence, we have plenty of, there are many networks actually that follow the same idea of Bitcoin, but when it comes to companies and organizations, they don't like this idea of having a totally open or public blockchain. So they want to have some degree of control. So imagine a case of, we have banks that want to use, so banks, they know each other, but they don't trust each other. They want to create a consortium of banks with a blockchain in the middle. So in this case, they don't want to use what we call permissionless, which is like Bitcoin or Ethereum. They went more for what we call a permission blockchain, where all the participants are known, we have access control, and then we can define a specific consensus among the participants. This is another idea. Then we have what we call a private blockchain, which, I mean, in my view, does not really make much sense, because it is one single company that controls the whole infrastructure. So I would say using a distributed database will even outperform what blockchain can bring in this scenario. But I want just to show you the different typologies of blockchain that we have. Then the last thing I want to share with you is, so far what we have seen with Bitcoin is that we have from, to, and some amount. So we use Bitcoin to send financial transactions. I want to send you some Bitcoin or receive Bitcoin from you. We can use it without having a problem. When Ethereum came to existence, it brought a much broader idea to that space, to this space. So now we have addresses. So address A will send to address B money, but we don't want to limit it only to financial transactions. What about if we can implement some logic? So instead of saying that address A sent to address B some amount, address A can define a piece or can deploy a piece of software that B can access or can execute. And so this would be the end of my presentation here. Now I want to show you a real demo of this. So I will go to my browser and I want to show you the first thing. So my computer is not here. So I want to show you two pieces of two demos here. The first one is I will use, I think if any one of you know what this is a crypto wallet. It's called MetaMask. You can install it as an extension to Firefox or I think also, yeah, or Chrome. And basically here, there are plenty of networks. So this is the Ethereum mainnet. This is the main network where basically I need to use like real transactions. But we have also a set of test networks. And one of them is this Rinkeby test network. And as you can see, I have 23 ethers in this account. If you guys, okay, you can do it later. If you install this MetaMask, and you send me your address, I can send you some ethers, always on the Rinkeby test network. Now, from here, like if I want to do what Bitcoin allows me to do, all I have to do, I can say send, and then I can write an address, a public key address of someone, and they can send it. How many do you have? You have Rinkeby address. If you send it to me over the chat here. If any one of you also has it, I can send you some ethers. I say send. Right, just bear with me. If you find it, otherwise I can.
No, I probably just need to change my mind first. Ethereum. Okay. Here you are.
Oh.
In the chat box.
So now the address is coming. Okay. All right. So I can take his address here. I say, okay, I want to send to this. I say next. And now it tells me how much do you want to send. So I can send him. Wait.
I think it was the previous one.
Yeah. Sorry. Here, the asset. Yeah. Here, I will send you 1 ether. I do it like this. And you see here, it tells me that this is the estimated gas fee. So this would be the transaction fee I need to pay. And let's say confirm. It is pending. I can also speed up by paying a little bit more. I can also speed it up now.
Sorry, but in this case, it is automatically broadcasted to all the miners?
Now, actually, what happens, it is broadcasted to all the miners, and the miners can decide to include it in the next block or not. And actually, this is an interesting thing to mention, because the miners, you know, the goal of the miners is to make as much money as possible. So they will check basically how much I'm willing to pay as a transaction fee and decide. So if you pay more fee, they will definitely include your transaction.
But in this case, because we are using Ethereum, it will be randomly assigned to one of the miners?
No, actually, the miners, they see all the transactions that have been broadcasted, and they can decide which ones to include. They cannot include all of them because the next block has a limited size. So imagine I am the miner, and I want to generate the next block, and they know that a block will hold or has space for 10 transactions. I will check all the transactions that have been broadcasted. I will rank them in terms of transaction fee, and I choose the top 10, the one that give me more rewards.
But like, how do you merge all the conflicts that can occur in the network? Because that's not clear to me. Like,
what do you mean?
For example, let's say that many miners try to perform some mining on a specific, create the same block, and then some machines, this block comes, and in some others, the block of another miner comes. Because having eventual consistency, we don't know the point in time in which we will guarantee convergence and consistency of everything.
Okay, so definitely, okay, so if I receive, we said before, for example, in Bitcoin, the goal is to have one block every 10 minutes. So after 10 minutes, if I receive 2 blocks at exactly the same time, like almost the same time, it will create a branch. If I receive the first block, I put it, then like 1 minute after I receive a second block, I will discard it.
Okay.
So I don't keep everything. So there are some time limits. So as soon as I receive a block, I attach it. So there are rare occasions where you find like 2 users or like two miners generating a block at exactly the same time.
But if, for example, I have 2 nodes, let's say on arbitrarily distant part of the network, and we have latency, and one of them receives, for example, block A, and the other receives block B, and after a specific amount of time, block A and block B are also broadcasted to these 2 counterparts, and we have actually a different history. We have in one first A and the next B, and in the other first B and next A. How do we handle this?
Sorry, I didn't get the point.
Yeah, it's quite difficult to pose the question, but whenever we actually have, for example, 2 blocks which are sent out by the miners, and these blocks travel around the network, and for example, a specific, these 2 blocks can be block A and block B, and if we have an host in the network which receives block A and another one which receives block B, and after a given amount of time, one receives block B and the other block A. So they have histories which are block A and block B, and the other one has the history block B and block A. Can this happen in the network, or it cannot?
You mean that they will? No, but don't forget, because the blocks, they have IDs. So I cannot, like every block, we know that now we are in block 9. So the next block I receive should be ID 10. Okay. So for example, if I received first block A, and then after some time I receive block B, they will have the same ID. So I will discard the second.
And okay, so if you receive a block which is like bigger than the one you expect, you just reject it, so it's lost.
If I receive a block with the same ID, I accept the first one, I reject the second. The rare occasions, if I receive them at almost the same time, there I create a branch, then I wait for the next block to arrive.
Okay.
All right. Again, here we're trying just to touch the different topics, and please let me know. So if you want, to go deeper in each of these topics, we can do it. Okay. So the first example I showed you, just basically to send this, make a financial transaction. The last example I want to show you is how basically smart contracts work. So instead of sending just a typical transaction, sending 1 Ether or 2 Ethers, this is a very nice, like a browser ID. It's called Remix to write smart contracts for Ethereum. And basically here we have a contract, a very simple contract called counter. So what we have here, we have a variable, and this variable will be stored in the blockchain, and then people can basically make calls to this contract, and they can call a function called increment. And you see, increment will change the state of this counter. It will increment it. Then they can also call another function called getCount, which is a view. So view basically means that it's only read only, so they don't have to pay anything. But if they call the increment, they need to pay the gas fee for this transaction. Again, you don't really need to understand the syntax here. But what I want to show you is now, the first, I will use the virtual machine. So I will use a local blockchain environment just for testing purposes. I will deploy my contract. It is deployed. Now, basically, I can call the function. So if I say get count, if you see here, there is 0. But if I say increment, now I call it again, it's 1. And this value, it has been saved in a transaction. Like a real transaction, this is the hash, the input, the output. Now, what I want to show you that I can do the same thing. If I use this injected Web3, I can use it here, you see, in the Rinkeby network. So I can deploy it in the real test network. By the way, this Rinkeby is a test network that is fully functional as the main network, but it is for testing purposes. So I will say deploy. And you see now, similar to what I did with the financial transaction, since I want to deploy this to the network, I need to pay some gas, okay, ether here. So I say confirm. And now it is pending. Just give it a moment, because this one basically goes to the real network, and now it has been deployed. Now, what I can do, I will copy the address of this contract, and they can go. There is this website called Etherscan. So Etherscan, if you put in front of it Rinkeby, it gives you basically the history or the ledger of the Rinkeby network. And I can go here and search for the address of my contract. By the way, I will put it here in the chat. If you want, you can check it yourself. So if I search for this one, you see here, it found my contract. Now this one is worldwide accessible. Here it says from, and if you see here my address is 743, and this is actually my address. So I am the one who deployed this contract, and I can go here to the contract, see this transaction. I can access the contract itself, and this is basically the bytecode of my contract. And they have also this utility called decompile bytecode. I can decompile it, and actually, let's give it just a second. I will refresh, because it takes some time.
But do we replicate the contract each time we do modify the state?
Actually, if you change the state, you replicate the contract, yes. And here.
But does, like my whole question with this blockchain is, does it scale? Because it looks like after an indefinite amount of time, this thing could explode. Like, I don't know if you get my question.
I get your question. Don't forget that one of the problems one of the issues we try to explain. For example, if you are building an application, you only use blockchain for the minimum necessary. Let me give you an example. There is a startup in Germany called Slocket. And they created an application similar to Airbnb. So basically to manage renting of apartments and stuff. So the renting application is managed off-chain. It's a normal, client-server application. The only time they use blockchain is, for example, when you go to book, and booking functionality is saved in the blockchain. So you only save the transaction to book the apartment.
Okay.
Everything else will be managed off-chain. I mean, blockchain is not really a database where you put your products and all the stuff. You only manage it for, like the transactions that need a trustless transaction. Otherwise, everything else you put it off-chain.
But then why does Solidity exist? Because
Solidity actually, it allows you to develop the smart contracts. Let me give you another example. So imagine we have a company, and I don't trust you and you don't trust me.
Okay.
So instead of having a bank account, a shared bank account where we put the money, then at the end of the year we split it, we can create a smart contract that all the transactions we make through our company, the money will go and will be locked inside that smart contract. And then we develop, I mean, logically we implement in the smart contract, we say that on the 31st of December, take half of the money, send it to my account, and half of the money, send it to your account. So we can basically build one of the terms that probably you would hear in the blockchain space. They tell you programmable money. So we can add some business logic on top of our financial transactions. If it doesn't make sense, we can talk about it more in detail. This one is taking a little bit of time. Let me see if I can. Okay, yeah, before actually it went fast, but now. Okay, in a way, here, this decompile phase, basically it manages, depending on how complex or simple the smart contract, basically it gives you back source code. Okay, yeah, it's a little bit slow. Anyway, but I want to just to show you this example. And as I told you, if you are interested, we can have dedicated sessions to touch on each of these topics. So with this, I will end my my part, and then I will give the floor to Hamid to go more into the financial side. So thank you very much.
Okay. Hello, everyone. Let me share my screen. I think, Nabil, you should stop your screen sharing.
Yeah.
Okay, then let me break this one down. Yeah, okay. Okay, now can you see my screen?
Yes.
Okay, perfect. Okay, perfect. Today I'm going to talk about what is crypto economy. In the first session, we saw Nabil explain very well about the blockchain, what is the technology behind the blockchain, and how this blockchain is booming nowadays, and many people, they talk about the blockchain. Do you have Bitcoin? Do you have any cryptocurrency? And many things like that. And now we want to see why we have this crypto economy and why it's become important, and why we should put it in under my radar, even if it's not let's say, even if we are not investing actively, why we should invest on this crypto economy and why we're living in this crypto era. A brief about myself for those who don't know me. I did my master in computer network and information security exactly in the year when Bitcoin was born and it was passing its first year of its birthday. I did my PhD in telecommunication here in Italy, in Politecnico di Milano, and here I did my postdoc with the same group of Nabil and Professor Klaus Pahl for the in the field of computer science and 5G Carmen. Then I moved to the crypto and crypto economy. In case you found my presentation interesting, you can get in touch with me through this QR code. You can find all of my social media. Through this link, you can have this QR code. If you want to leave me an email, okay, the email exists here. Then a brief about the research topic now I'm interested are listed here, and mostly now I'm working on the distributed ledger technologies, blockchain, crypto economy. What I'm going to talk about within this, let's say, less than 1 hour, I'm going to talk about the blockchain in a nutshell. What Nabil explained, I'm not going to explain it and repeat it again. I'm mostly going to talk about what is money and what is the relation of the blockchain and money. What is the money evaluation about the digital currency, about the cryptocurrency, Bitcoin, and why Bitcoin price from a fraction of cent it raised to the current price. I don't know if any one of you knows the price of Bitcoin today. Any idea today how much is the Bitcoin price?
I think it's around 55,000.
Okay, then it seems you are tracking the market.
Yeah.
Okay, perfect. Good, good. Okay, then I'm not going to explain about the blockchain since we saw in the previous time about the blockchain and what is blockchain. Just a brief things about the blockchain. We saw about, we have a block, okay, which is important for us. We have the ledger, and this ledger must be distributed. Then we have the transaction, okay, and this transaction must be confirmed through some devices, which we call them as a miner. And the consensus here we have works based off the proof of work. And if everything goes well, those miners, which they did the correct transaction and confirmation, they will receive this block reward. Okay, about the money, our ancient people start with the barter. Okay, they start with the barter, then we went for the gold bar and the metal coin and then paper money. And nowadays, mostly we use paper money and plastic card, which we call the credit card or the debit card with the consortium of the Visa or the MasterCard, or even Maestro or the other consortium which there exist. Then the next one was the digital money, which this digital money also exists in this plastic card, because plastic card, they have a sort of digital money because money went digitalized and inserted into this system and this card. And we use now also we use this PayPal to transfer money. The next phase is this cryptocurrency. Is it correct if we call it currency? I mean, it is not really correct because it's not currency, okay? It is current, but it's not currency. Is it crypto? Yeah, of course, it's crypto. For me, the correct form to call it, it's crypto assets, because mostly we use them as assets. Okay, you know, the first things first, we start with the debt. Okay, our ancient, they start to have a debt and they borrow. Okay, it was the first form of the money. Okay, I said I gave a tomato to my neighbor, and okay, now I have in my ledger, my neighbor owes me a tomato. Okay, it was the first form of the money in, like, let's say, years ago. And then we start with the barter. Okay, we exchange our goods together. We pass the fish, receive the meat. Okay, but it was not sufficient to have a proper economy. We couldn't come to the agreement. Is it fine, the 1 hour work for the, I mean, fishing, with the 1 hour work for the, I mean, for farming? Are they equal or no? Then it was many problems. Another problem, it was not really easy to transfer this money from one geographical area to another place. Then people, they start to found new achievement, which the first one of the first, let's say, one of the first form of money was a seashell. Okay, in Africa, in Asia, they use seashell as a first form of money. Can you imagine? This one was money, and people, they did the trade with that. Okay, but now for us is not useful. Salt also was money. Okay, pepper was money. Okay, but there are many problems behind of these form of let's say money or currency, because if they could hold it for a while, then they expired, it become useless, and then people, they cannot, I mean, it couldn't hold the, let's say, it couldn't hold the value for a long time. Then they become more let's say more intelligent, and they start to find some scarce asset, like some scarce metal asset, because shells was okay scarce, but it was not really scarce. Then they start to use copper and the silver and gold. Then, but it was heavy for transportation. Okay, then they said, okay, instead of this bar of gold, this form of gold, we can have a coins. They start to have a gold as a, let's say, as a first, one of the first form of the real money and currency. Here in these two coins, you can see difference. You know, what was the first security aspect with the coin? It was this, you can see in the edge of the coin, okay, we have some cutters, and these are what the first form of the security for the coins. This coin, it doesn't have, this one, it doesn't have this security part. Then people, they start to cut from side of the coin, and then with the many of these coins, they start to build a new coin. Okay, then the government in that time, they realized people, they cheat, and then they start to add these things on the edge of the each coins. Then they said, okay, if we want to go from one city to another city, one country to another country, is not safe and is not convenient to hold the money, and I mean these let's say this gold money, and to go to another city, because you know many thieves are on the way, many people, they can steal their money. Okay, and it was not safe. Then they decided, okay, instead of sending money, okay, and I mean holding money and transferring money, why not we use it to exchange people? Because in the first form, it was some exchanges in one city and another exchange for another person in another country or another city. They decided, okay, we can have a sort of relationship between us, among us. Then I can write a piece of paper and I say, okay, this person, okay, gave me 1,000 coin, and this piece of paper has a value of the 1,000 coin. If you submit this one to another person, okay, then you can receive the same amount of coin minus the exchange fee from the other exchange in the next country. Therefore, the first form of banknotes come to the world, and we saw it was in China, and Chinese, they start to use this first form of the money, or let's say now we should call it from now on not money, we should call it currency. Then fiat money, after that one, the government, they start to make, okay, the same procedure. Then we can see for a long time, we didn't have that much improvement for the form of money. For a long time, we used this paper banknotes as a currency. And when we need to go from one country to another country, we have to hold it with us and take it with us, and to use it over there. And the people, they start to say, okay, the money of one country has this much power in compared to the other country. Then after that, this form of the plastic card, this Visa, Master, they start to make like a connect different banks, and they make a one circle, and through that we could pass the asset value, which it was this money. And now we are in the generation of the PayPal, and we use PayPal and plastic card every time. And when we need to buy, I mean, something on Amazon, something online for our online shopping, we mainly use this PayPal and plastic cards. Okay, then we need a bit go back to talk about the form of money as a fiat. Just if you want to know, this currency here we have, and I mean euro, dollar, yen, and whatever currency every word in the world we use, we call it as a fiat currencies. Okay, it has the story after, I mean, the Second World War, the global economy, they realized, okay, economy cannot work in the previous way, and they have to change it. They start to change it to the dollar backed by gold. Then in the Bretton Woods Consortium, an agreement, they made the dollar backed by gold, and it was dollar was representing the gold, and each banknote of the dollar was like a receipt of that same amount of gold in the US Treasury. Okay, but unfortunately in 1971, okay, year 1971, the President Nixon decided to remove gold as a backed of dollar. Then we can see what happened with the economy of the US. But US was, in that time, was the world leading, even now is a world leading. Of course, many countries now beating US economy, but still US economy is the greatest, the biggest, let's say, economy in the world. And we can see this is the amount of inflation we have. But what is inflation? It means if you have a dollar now, tomorrow must have the same value as today. Okay, but here we can see from 1913, okay, the value of the dollar is going down and down, and the value of, I mean, the real value, the value of the work, the value of the gold, the value of whatever you do is going high. And why this is happening? This is important to know, okay? The main reason is scarcity of the asset, okay? Here we can see when Nixon says, okay, in 1971, after Nixon said, okay, we removed, okay, the gold from back of the let's say dollar, it went drastically. In 1973, $1 worth was like 30 cents, but in 2013, the worth of the $1 was less than 5 cents, and now even is much lower. Here we can see, okay, amount of money, amount of the money, I mean, in a dollar in circulation is raising, okay, and then just imagine in this way: you have $1, your friend has $1, you want to go to the bar or to the, I mean, bakery or wherever, and you want to buy a piece of bread, okay, and that person wants to sell it higher, okay, and you both willing to pay $1, okay, and that person wants to increase it, then you have like $2, okay, both you increase it by the double, but for the same bread you must pay like a 2. This is the simple explanation of the inflation. You have an asset which is not scarce. Everyone has an access. During the pandemic, American system, they printed 30% more. What does it mean? It means they propose many inflation in the coming years, okay? It means if you have a 1,000 euro in your bank account, it will be impacted with this 30% more inflation. Okay, in this chart, what I want to show, you can see in 1971, after Nixon removed the gold back from the dollar, the price of the gold went high drastically, like 5,000% higher. Okay. What does it mean? It means if you had the same amount of dollar and the same amount of gold you want to buy, you have to pay 5,000% more to have the same amount of gold, okay? And this is happening. If you know Robert Kiyosaki, he always talks about the good money and bad money. He called gold as a good money and the dollar and euro and yen as a bad money. Then this one is a price of the gold in a vice versa. I just reverse the chart to see how the price of dollar is going down in compare. Here we can see how the price of dollar is going down in compared to the 1 ounce of gold. Okay, we saw okay about the dollar, but what about the euro? This is the most updated one I found in internet. How inflation earns the value of 1 euro over the time. It means if you hold 1 euro in 2000, and okay, now we are in 2021 and almost 2022, you can see if you hold the euro for your pension, you will be the loser, okay? Because it's lost its value by minus 30%. But why? Because euro will be printed by EU and they can print it as much as they want, okay? Then it doesn't make sense to hold the one asset which it goes low and low in terms of value. Of course, euro is good if you want to do for, I mean, day trading for your shopping, for these things. It is good, okay? It's acceptable across European countries. It is good, but it cannot hold the value for you. If you want to hold the value for your pension, euro, dollar, or any form of fiat money, it is not good at all. Okay, this is, we can see from 2007, almost 2006, 2007, if you hold the euro or the same amount of gold, we can see, okay, this much of almost 300% lower. Okay, it means you lost by 1/3 of your value of the asset. Then in 2008, as Nabil mentioned, some pseudo name, group of people, person, she, he, nobody knows, put everything in terms of security, in terms of computer science, in terms of the economy all together. And he introduced some peer-to-peer electronic cash system, okay, and called it as a Bitcoin. And this Bitcoin, it was in January 2009, the Genesis block recorded, and from that time, it's working non-stoppable and till now is going on. I took this screenshot just now before we start this presentation and this webinar. We can see we have more than 15,000 crypto assets, which they are claiming we are the new Bitcoin. It was a fashion for years. We are the new Bitcoin. We are the new Bitcoin. Okay, but none of them they can replace the Bitcoin till now. And this market has a market cap of $2 trillion, more than $2 trillion. And in the last 24 hours, it has this much of volume. But the important part is here. Bitcoin itself, out of these more than 15,000 crypto assets, has a more than 41% of this market cap. And Ethereum, as a second one, has like more than 20%. It means this market, which it has more than 15,000 crypto assets, more than 60%, 61% of this amount of market cap, it's only belong to Bitcoin and Ethereum, okay? Because Bitcoin was the first one who provides this technology, okay? It was the novelty of the Bitcoin. After that, we had Bitcoin Cash, Litecoin, many forks of Bitcoin, okay, which they don't have, to be honest, that much value as Bitcoin has. Then in other coins, they become like famous in those times. And then Ethereum, what was the novelty behind of Ethereum? It was the smart contract. And now we have the same talks and say, okay, we are Ethereum killer. The another one, the many projects, they talk about Ethereum killer. Bitcoin has many killers, none of them win. Ethereum has another, many Ethereum killer, but let's see what they can do. Okay, in terms of the, let's say, in terms of the money we saw in the market, let's say, the amount of money we have in hand, okay, and we can see in the form of the physical cash, okay, which is printed, okay, it is only 8% of the world currency exists as a physical cash. It means anytime government, Federal Reserve, or EU, or whoever is in charge, they decide to print money, even they do not need to physically print the money, okay? Just they need to put some money in circulation, okay? In the computer system as an electronic cash, they can put it, just they can add it. And we cannot understand how much money they are printing. But in, let's say, in blockchain, everything is visible. We can see all the transaction, who transfer money from which account to which account, okay? But if their wallets are not well known, we cannot understand who are the people behind. But of course, we can see the transaction. For most of the, let's say, for most of the coins and tokens out there, except those they work based off the security, like in Monero, like a Zcash, we cannot see, okay, how much they are transferring. This is the amount of Bitcoin I took a screenshot. It's a bit old. It's not for today price, but we can see, okay, the maximum supply of the Bitcoin it's 21 million, but it is not 21 million. It's 20, let's say 29,999 million, but they round it to be like a 21 million. Then the total supply is the number of the coin which everyone has it as a part of it or the whole Bitcoin. Okay, it means this amount of the money people they hold it in their wallet. Many of them they lost. They are expecting more than 2 million Bitcoin they lost. I'm one of the guys who lost a lot of Bitcoin because in the beginning we were not expecting price of Bitcoin will go that much high. Okay, Nabil talked about the Bitcoin halving when the block reward every approximately 4 years gets half. Okay, it started from 21 million in 2009 in 3rd January 2009 in the Genesis block, and the block for almost for 4 years was like 50. Then it become, here we can see, then 25, then 12.5, and now we are here. Okay, the last halving happened in 2022, and now the miners they receive 6.25 as a block reward. Okay, what this chart will tell us, we have in one hand the Federal Reserve, the European Union, the Chinese government. They can print money as much as they want. Okay. In the other hand, we have a Bitcoin, which every 4 years the block rewards will get half and half and half and half. Okay. That's why people and they call Bitcoin as a deflationary asset. This is the main reason we call Bitcoin as a deflationary asset. What does it mean by inflation and deflation? It means in 1928, with the $20 of banknote, you could buy this amount of, let's say, goods. You could do your shopping. In 1996, it shrinked. In 2017, shrinked. In now with $20, almost you can just have one, like a 2 burger in the McDonald's, nothing more. But if we go for the Bitcoin, when it starts, it doesn't have any value. I was mining. I had a like a Dell Vostro laptop, and I was mining Bitcoin in that time, and I received many Bitcoin. And I said, but it doesn't have any value in the market. Okay, and I was among those guys. Said, okay, this guy, this Satoshi, or whoever behind it, just made it for game. I think there is a problem with my connection. Because it shows me, hold on. Can you see my slide?
Yeah, you can see your slide.
Because, okay, then I can. I mean, the other, do you able to hear me?
Yes, yes.
No, I mean, the other students not in the same network. Can you hear me?
Yes.
Yes.
No, it seems. Can you talk? I would just want to see, is it my system problem?
No, they can hear you as well.
I cannot hear them.
Sorry, guys. Hamid will connect again. Okay. Yeah, they could see you anyway and hear you.
Okay, now it's in rejoin. Okay, now?
Okay, now you joined.
Okay. Okay. So I have to share my screen again. Okay. Sorry, I don't know what happened. Just I disconnected and can you hear me now?
Yes.
Okay, perfect. Can you see my screen as well? Yes.
Yes.
Perfect. Okay. Okay. This is I was talking about inflation, and I think they caught at me. Just kidding. Okay, and this is a story is really happening. If you have a 1 Bitcoin, people they talk about the $1 million for the worth of Bitcoin in the 2030. Okay, or even 10 million, and you see, okay, it is not possible. But since they can print more money, you can buy more Bitcoin. Okay, this is the rationale behind. I want to say one example, which it happened for me. And let's see on the chart. This is the Turkish lira, okay, equivalency with €1. During the August, I was in Turkey, okay, and I was exchanging €1 for almost 10 lira, Turkish lira, or like a €1 for like a 9.5. It was the equivalency. It was the exchange rate was like that. And now we can see from the August time when I was in Turkey till now, the price of Turkish lira, it lost its value like a 51%. What does it mean? It means if I spend in Turkey like a 1,000 euro for that vacation, if now I go for the same vacation, okay, I have to spend like a 500 euro. Okay, this is the inflation. But why in EU we cannot see that much increase over the time? Because the economy of Europe is strong. Okay, the economy of Turkey is not as strong as economy of Europe. Okay, this is the main reason. But you can see here from 2010, okay, how much is the difference between 2010? It was like a €1 was equal to 2.1 lira, and now is like a 15. It's like 7-8 times higher. Okay, this is the inflation, and this is exactly happening for everyone, because whenever governments see, okay, we don't have money, just they print. We need the money to pay for COVID, they just print more. And if you do it, it's a crime. But if government does, for them, decide it's not crime, it's our economy. Okay, but in the end, as a result, is our bank balance as a saving for a long run for our pension, it shrink and shrink and shrink. Okay, but why attract my attention? It was the COVID. In the COVID, economy was going well. Then in March 2020, the economy for everything crashed, and now you can see with this new pandemic, with this new variation of the COVID, again markets are react and the price went down. Okay. One of the things it was for me really interesting, it was the price of US oil. It went to negative. What does it mean? You have an asset and the price of asset goes to negative. And it attracts my attention. Okay, for me it was not acceptable. Then I start to do my research. This one was published by, the source was the Bloomberg, BBC, and many of them they published, okay, this one, and this one was on the BBC. We can see the price even went below zero. It was negative. Then, okay, this is the chart. If you go, there's a website, by the way. The chart I get, the data I get is from the trading view. You can find all the data over there. Okay, you can see here in the chart, okay, the price, how deep it went in 2020. Okay, in the same time for Bitcoin, it went like minus 58%. When we say like a 60% down, it needs like 130, 140% increase to come in the same level. Then I start to my study and compare Bitcoin and crypto economy with the other commodities like gold, oil, and silver, and many things. Okay, here I did the same comparison for the Brent crude oil versus Bitcoin price. We can see more than 4 million% oil, okay, is losing its value against Bitcoin. I did the same study for Ethereum. For Ethereum, Ethereum in the beginning, it was not inflationary asset, okay? But now, because it's changed something in their platform, now even Ethereum becomes inflationary asset. And we will see in the future the price of Bitcoin and Ethereum and those assets which they are inflationary, in compared to the other asset, always will increase and increase and increase. Okay, it's the price of Bitcoin from 2011. If we put this chart in this way, okay, as a not logarithmic scale, maybe we guess, okay, in the beginning Bitcoin didn't do that much, then it start. But we have to, since here we entered the mathematics, we have to scale this chart in a correct way and have a correct look on the price of Bitcoin. This is the same chart from the same source. This is a Bitstamp. Yeah, this is a Bitstamp. This is the monthly price of the Bitcoin. This one is just took it like 1 hour before this webinar. The price is like almost 57,000. Okay. When we put it here in a logarithmic scale, we can see how much it's increasing over the time. Okay. In the beginning, it was huge amount of benefit for those people. They bought here. I mean, let's say those Bitcoin believers, they bought Bitcoin here, and till here they have, I mean, even if you have one Bitcoin, you paid like a fraction of cent, and now it's worth like a 57,000. But where will be the end of this crypto? I don't know. No one knows, okay? Because this is the narrative. The narrative says Bitcoin is going high and higher, high. And many people, they call it as a bubble, okay? Like a tulip bubble in the Netherlands, okay? They call this is bubble. In a day, someone will just put the pin on it and it will explode. But this narrative is strong. And in the next slide, I will show you the comparison of the Bitcoin with the other assets. Let me check. Okay. Okay, what we are expecting to see in the end of this year or in the Q1 2022, somewhere around, we can find the top of Bitcoin, which it can goes all the way up around 200 to 300,000, and then Bitcoin will have this correction and will come back around this price. Now we have our even lower, like a 36,000. It depends to the many things. One of them is a market manipulation. Governments across the world, they understood, okay, people are interested, and they start to ban Bitcoin in many countries, but still Bitcoin found its way, and many, let's say, young people especially, they would like to invest on Bitcoin. Okay, and this is the way the Bitcoin will go. And some people, they think, okay, where we can buy Bitcoin? Mainly for Bitcoin or any other crypto asset, you have some options, okay? One of them, and the easiest one, is the centralized exchanges, like a Binance, like a Coinbase, like a Kraken, Huobi, KuCoin. These are the centralized exchange, which they provide conversion of the fiat money to crypto. This part is difficult for mass adoption, and it was, let's say, much difficult in the past. People, they didn't know how to let's say, how to convert their fiat money, euro, dollar, to the crypto assets. The first step then is centralized exchange, and the next one is when you enter to this let's say, to this space, you have many other options, like a decentralized exchange. Here, most of the transactions are anonymous, okay, like partially anonymous, okay. You can transfer your money among your, let's say, among your crypto addresses, and you can exchange your money between these exchanges. And these decentralized exchange, they have this screenshot is for today. Just now I did it. They have like more than 100 billion. We call it as a total value locked, TVL in dollar. It's locked in these platforms. If you want to just, this data are for 2018, but since just they want representing, I took this this slide. But just I want to show you how big is this the world global let's say global market. Bitcoin, it was in that time 213 billion, but market cap. But today, market cap of the Bitcoin is more than $1 trillion. This one just wants to compare the net worth of the Bill Gates, Jeff Bezos, and let's say the Apple stock and the other one. But in the next slide, I will show you the exact number, but this is just for a representation. Okay, this is amount of the money we have in the world. The first one in the world is Chinese yuan, then American dollar, then euro. And then we can see in the rank 14 is Bitcoin. It means Bitcoin economy is as big as the global economy. If we go the next slide, we can see, okay, Bitcoin in 14 is bigger than Russian ruble. It's bigger than the economy of the Russia, bigger than economy of Saudi, because Saudi has a lot of oil resources, and bigger than economy of the Mexico. Mexico has a lot of land. Okay, we can see Bitcoin economy is bigger than economy of the many other countries. Also, the second thing is interesting here is Ethereum. Ethereum is a, if you go and study about Ethereum, Vitalik Buterin found Ethereum, and it was the competitor of not, of course, Bitcoin. It was the first platform to run a smart contract. Now, the total money let's say the money of the Ethereum is, the market cap of Ethereum is bigger than the Israel and shekel economy, bigger than the Swedish krona. Okay, we can see bigger than the UAE, the Emirates. Okay, which is huge, and this is it's a start in 2008, and then with Ethereum start in 2000, if I'm correct, in 2015, if I'm not correct for the year. This year, we saw the first country in the world, they accept Bitcoin as a legal tender. It means now Bitcoin is a currency, official legal currency in one country, which is the part of the United Nations. Okay, El Salvador is the first one in the world they accept Bitcoin as a legal tender, because in El Salvador they do not have their currency and they use a USD. Therefore, since they don't have, they decided to have alternative, which is the Bitcoin. Okay, and now you can see many news about about El Salvador with Bitcoin, because they are growing together. And the other countries, they put the small countries, mostly for the countries for South America, they consider Bitcoin to be alternative to their currency. Okay, let's in this slide just to see about the how big is the market cap of the Bitcoin. The biggest company in the world market cap is for Apple, okay, with this is the market cap, okay, with the market cap of $2.7 trillion, and the market cap of the Bitcoin is $1 trillion. Okay, Bitcoin almost is going to do the flipping with the Tesla, and very soon we can see with the Amazon. Okay, but by the way, guys, Bitcoin doesn't have any centralized office. Bitcoin doesn't have any centralized company which behind of it. Okay, but all of these company, they have the centralized office, they have the CEO and people they know who is behind. Okay, but Bitcoin, it doesn't have these things. Bitcoin is going with the narrative, and the narrative is the inflation. Okay, here we can see of Ethereum is market cap is bigger than the JP Morgan, bigger than the Johnson & Johnson, okay, bigger than a Visa, the plastic card every day we use. All of the things I mentioned are not financial advice. I'm not a financial advisor, I'm a researcher, just I'm sharing the result of my research with you. But just I took a screenshot from a website. You can see here in the link from the Glassdoor. The average salary for people in Italy is 28,000 euro. But what you can do with this money after taxation, okay? What you can do in terms of the your pension. In 5 years ago, if you only spend $1,000, it could reach today 1.3K. It means 1,300. It was not that much if you invested on a gold. If you invested on a Google, it could raise to 3 times. On Amazon, 4.8 times. If you invested on a Bitcoin, could reach to $148,000. If you invested on a Ethereum, it could raise 216,000. Okay, with only 1,000. And how much was the salary? 28,000. Okay, then I'm not suggesting you to do any investment. What I suggest here, just do your own research to understand how economy works, because this market is really, really young, and it has a lot of upside and downside. Look at this one. It has happened just days ago, and the market went down. We can see if you invest like last Saturday, Sunday, the price crashed like a -7% on Bitcoin, 8% on Ethereum, and the other coins, they crashed. Okay, then it is really dangerous. I show you that the downside, if you do not know anything, this market in a fraction of hours can go down like a 20% correction. And to recover this 20%, you can see, we need a time, okay? And people, they will panic sell, and they will start to sell whatever they have. Then do your own research. If you found it interesting, there are plenty of social media, YouTube channels, they explain better than me, okay, on the YouTube. Just do your own research, because in this market, what you see mainly two things. You see FOMO, oh, I lost it, okay, I lost this opportunity, where I can find the next opportunity. The another thing is a FOD, which now we are in a FOD, because those people, they bought in the, let's say in the last week, and now the price is in this situation, and now they have this FOD situation, and they don't know what they do. They lost like a -8, -10% of their value. But this is the psychology of the market. People, they start with the optimism, excitement, then they go to euphoria, and they say, okay, we are genius, let's buy more. Exactly here is the top of the market, and those people, they bought here in the downside of the market, they will start to sell it, and then you will go down and down, the price will go down and down, you will go emotionally with your asset down and down in the capitulation, and then again they will start this one. Let's see the next slide, the real example. In 2017, when the price of the Bitcoin start, many people say, okay, Bitcoin dead, it will go to zero, it will not do anything. Price start hoping on optimism, euphoria. Even here, I know many Bitcoiners, many maximalists, many people, they say, okay, buy the dip, buy the dip, buy the dip. But it was not a dip in that time. Then the Bitcoin crash, anger, capitulation. They start to sell and sell more, okay? And then again, Bitcoin in 2019 start after this long run. Here in a chart is easy. We can see it easy. Okay, it's nothing. But believe me, I'm in the market for a while. I know when the market crash, and you can see the value of your asset, which you start to dream. If it's raised with this much, I can buy a house, I can buy a car, I can buy a laptop, okay? It will go down and shrink, and you will lose your patience, and then you will sell your asset. That's the time the people, the real investor, they will buy and then have a look. Okay, in the next time it was a disbelief, and then market was going down. Pandemic happened. People, they said here, almost here, they said Bitcoin will go to zero. And then here is Bitcoin start to recover, and it went to 33,000. And today price of the Bitcoin is 50, we saw it together, 50, 54, 57,000. And this deep, actually, here was a deep. It was in the top. 2018 was a top. People, they call it as a deep, but when we compare it with here, it was a deep. But look, in the Bitcoin, it's a matter of time. It's a matter of when, but not it's a matter of if. Okay. To conclude my presentation, in the first part, we saw about the blockchain and what is blockchain. what blockchain is doing. Then we saw about the definition of the asset, money, and how we can save the value of the asset with Bitcoin, with gold, of course. We saw some guy and the name, some group of people, pseudonym as a Satoshi in 2008. He invented the Bitcoin, and in 2009, he released his open source software. And then now we have a market which is mature, like 12 years, and we can see this crypto economy. What I can suggest: don't FOMO, don't FOD, just do your own research and buy or sell, but not with that amount of money which you are not willing to lose. Okay, if you are not willing to lose, then don't invest on it. Then it was okay that we can go for the question and answer. And thank you so much for your time. What I can suggest: just think different, not the way we thought in our life, okay, till now. Just think different, out of the box, to see what is more beneficial for you. I have a Telegram channel, which of course you can find it in this link. All of my Telegram group channels, Instagram, whatever. I start to provide some content in English as well. You can follow me if you would like. You can see what is my perspective, what is the new result of my research. I'm sharing mostly result of my research, and if you find it interesting, you can of course share it with your friends and colleagues. Thank you so much for your attention. I will close this
I have a
presentation.
question.
Yeah, sure.
How safe it is, as for your opinion, in your opinion, to keep, let's say, if I invest in some cryptocurrency, to keep it in an online exchange portal instead of keeping it like in those, I don't know how it's called, like cold keys,
wallet. Yeah,
cold storage. Yeah.
You for those one, we say if you don't have your key, it means you don't hold your wallet. You don't have your asset. Okay, then whatever you do not hold it with inside of your wallet, it is not your asset. In the exchanges, mainly, they have their your private key. Okay. Then you want to say they are not safe. They are safe. Okay. But is it your wallet? Is it your asset? Of course, it is not your asset. It is exactly like as a bank. Okay. Bank can get hacked. Of course they can. Okay. But exchanges, can they get hacked? Many of them in the history we can see, many of them it happened. Okay. But for you as a beginner, what I can suggest, you can start with a small amount of money, okay? Just to keep it even in the exchanges. Try to, with some crypto asset which they have a low transaction fee, to start to doing your research, okay? To transfer some money from exchanges to out of the exchanges, to see how you can do it. When you become confident, okay, then just you will buy on an exchange and you transfer it to your own personal wallets. Mm-hmm. But in general, exchanges are not safe. This is the general recommendation.
But you mean only physical wallets, like with where you have the key?
No, physical. It's not only physical wallet. You can install it on your laptop. You can install it on your phone. Okay, whatever you would like, you can install it. You can buy a device, but as long as this the copy of your seed phrases is not online and it's not connected to internet, and you don't take a screenshot, you didn't write it down and pass it for a friend, it is safe.
Okay, thank you very much.
Welcome. If there is more
The goal
question.
here is different way. Once you hold your private key,
You are muted, Nabil.
sorry. No, I said as long as you hold the private key, so in principle, you have control. So, yeah, please, Stan, did you have a question?
Yes, I was just wondering that for sure you, both of you probably invested in these cryptocurrencies and also got some revenue out of them. If you get the real money out of the cryptocurrency, how do you deal with real taxes, let's say?
Hamid, do you want to answer?
Yeah, just let me unmute myself too. For the tax, I think if you can just mute yourself.
Yeah, sorry.
Thanks. For the taxation, look, I should say now we are passing the gray time. It is not white, it is not black, okay? You must declare your taxation, okay? But we have different types of taxation. We have like a capital gain tax. We have the, let's say, the trading tax. Okay, it depends to which sort of earning you have. Okay, this taxation, it needs many regulatory. Okay, and for the moment, no one knows. If you go to fill your form for this Sette Trenta, okay, they say, okay, which one should I fill? Should I put it as my income? Should I put it because some coins you receive as an airdrop? That one, you don't want to receive it, but someone sent it for you. Is it taxable or no? Okay, this is still needs many regulatory. Okay, and for the moment here in Europe, as far as I know, is not a clear answer for this taxation. It's based off the trust, and if whatever you declare based off your earning, that they will count it as your tax.
Okay, so in case of the Sette Trenta, you have to declare it as a sort of income, and then based on everything, you will get a taxation on the overall.
True.
Mm-hmm.
True.
Okay, thank you.
Welcome.
Right. Yeah, and as I told you guys before, so if you are interested in any aspect that we sort of mentioned very briefly, whether technical or financial, you can come back to us. I mean, the goal is based on like the interest we see. We can organize more events or have hopefully face-to-face meetings as well. All right. Any other questions? Okay, so if not, I would like to thank Hamid first, and I would like to thank you guys for joining us. And yeah, I hope to see you soon in class, or we can meet for coffee and you know, talk and chat about cryptos and about blockchain. So thank you again. Thank you very much for joining, and see you soon.
Thank you for the seminar.
Thank you.
Yeah, thank you very much for sharing this knowledge.
Thank you guys. Okay.
Thank you guys.
All
Thank
right.
you. Bye.
Bye bye. Bye.
Bye bye.